My name is Denise Gosnell. I'm with DataStax. I'm their global graph practice lead. I like to take the moment always when I am up here to thank Lynn for a very specific reason. And it was something that through the conversations I was having last night with some folks, I remembered over the journey of being at Day to Day and through the now Global Graph Summit. Being here, how many connections I have made and how different that has changed not only my career, but also others who have found other job opportunities because of the people they've met at this conference. So it's a graph. Our conference is a graph. Find your connections, make some networks, and maybe who knows where you'll be with your own career in a few years. But before I get started on my talk, where I'm going to be walking through 6 lessons that I have learned from helping either build, advise, production graph applications, I want to set a little bit of context as to why I'm here and to what got me here today. Honestly, it was an accident, complete accident. I was getting ready to register for my courses in my master's degree in math, and I was completely locked out of all the classes you needed, like abstract algebra and number theory. And the only thing I could really wanted to fit into my schedule was this class called graph theory. And between registering for that class and showing up to class on the first day, I was like literally dragging my feet, not excited about having to study bar charts and pie graphs for an entire semester. And thank God that is not what we did. And within the first few moments, my advisor and longtime friend of mine, Dr. Teresa Haynes, she put something like this up on the board. And she explained how this was a new way, at least new to me at the time, a way to look at data and relationships. It's your friends of your friends. I'm Denise, that's D. And this could be who I'm connected to. It's the friends of the friends graph. And the only way I can really explain over 10 years ago what that felt like for me, and still feels like getting to be here with you all today, this, for me, was a real moment of enlightenment. My mind opened up to a way to get to look at and model data in a fashion that I had never seen before. And it gave me the ability to start studying new metrics and apply math in something that made me feel more connected to the real world and how we process the real world. And so for the past decade or so since I got to take this course and work with Teresa and work with many other fantastic researchers and teams around the world since then, over the past decade, I've collected some patterns of what's working and what's not working for people who are trying to put graph data into production. And so I'm warning you, a hard right-hand turn is getting ready to come. For those of you who may have seen me give this talk before, I'd like to parallel my 6 lessons that I have for making graph data successful or not in a production application with playing my absolute favorite game from my childhood, which is SimCity 2000. So what we're really doing here today is reminiscing about the 90s. So who remembers the 90s? All right, and who's played SimCity or any other sim game? Keep your hands up, because look around. The intersection of people who love graphs and data and played SimCity are probably all here. But for me, this is what this talk is going to be about. And what we're going to walk through, we are going to walk through 6 lessons that I have learned. And for those of you who maybe have never played SimCity or want to remember or about to go pick it up right after you leave here, you start here. It's a game about taking a map or a topology and learning how to turn this into a really successful metropolis. So you start at the beginning with nothing, and you find successful ways to have small communities spread across your map. And your goal state is to make the mega metropolis that is self-sustaining, the resources aren't constrained, and it's good to go. You can just leave it running on your desktop. Yeah, because desktop in the 90s, that's what it was running on. Anyways, so the 6 lessons that I have kind of gathered, and we commonly talk about at DataStax, and when I'm advising companies around the world, these are the 6 lessons that draw parallels both to SimCity and to running production graph applications. So I'm asking something quite large of you all. I'm going to be asking you throughout this to flip not only through some deep, potentially deep graph concepts, but then remembering, oh yeah, we're talking about a really cool video game, or at least this presenter up there thinks it's really cool. So we're going to be flipping between these two topics throughout the next 30 minutes or so, and I'm going to do the best I can to make sure that we keep you guys on time. But to get started, when you're starting and building in SimCity, the first thing that you need to do is you need to focus on making money. It's all about making money first and then dealing with the aesthetics of the game. You cannot let that super cool, if you remember it, like twisty spaceship with the people living on top, like you can't let that distract you from remembering that you have to eventually get there in the game. So for anyone else who maybe has played this game way too much, which apparently that's all I'm doing is telling you all I have played this way too much, this is kind of like a self-sustaining community for the aficionados out there. This community represents a pattern of applying all the rules in a fashion that your resources are self-sustainable. So the rules in SimCity here, you got to have fire coverage, police coverage, residential areas, places for your residents to work, power and plumbing, and things like that. And this example small community is stuff that you can start to put all over your map to start to generate revenue a little bit at a time. I want to draw that parallel over into the graph world. That parallel to me is to focus on getting into production first and then the aesthetics. For those of you in here who have worked with graph data before, you have experienced this gap. So I'd like to just take a poll now that we've kind of had everyone settle on the transition. I'm going to ask you guys to vote, or at least let me know where you are in using graph data. And we're going to start with raising your hand if you have a graph data or a production application that's using graph tools or graph data. Okay. Raise your hand next if you have like a developer, like a dev cluster, maybe a testing cluster, just on your laptop. You've downloaded it and you're using it, tinkering, trying to figure it out. All right. And lastly, or if you're here kind of new to the world, you're here because it's day-to-day and I love data and I want to figure out more about graph data. All right, this is the place for you. This is the place for all you guys because I've got lessons across all the stacks, or all those different groups. And when you're thinking about what it means to get into production and to translate yourself from wanting to learn about graph data and make something useful in production that your business is going to value, you need to identify your MVP. All right, this is not new to the graph world, but the graph world has been forgetting about this step, in my opinion, for the past 5 to 10 years. The allure that my data looks like a graph and I can explain my whole world like a graph is causing us to forget about making small, tangible steps into developing production quality applications. The MVPs that I recommend when I'm advising companies around the world look like finding out, or at least getting CRUD working for you, getting the ability to create a graph, update it, delete it, things like that. If you need to focus more on graph analytics, make sure that that's siloed in some infrastructure so that your data science team has the ability to understand the topology and the connectivity of their graph data to better inform your production application later. You need to find out for your team what that's going to look like and break it down as small as possible. And you're probably going to need to push back up. You're probably going to need to push back up your exec chain to the... We need to start small and deliver well. Flipping back into SimCity, if you guys are going to get started with this game in your free time afterwards, your bulldozer is your friend. Your bulldozer is the CRUD for SimCity. This is how you level terrain, you raise it, you lower it, you delete the mistakes that you've made. And so the first lesson that I'm asking you all to think about for those who want to start your journey in graph data is to find your bulldozer for your application and to get that into production. The muscles that you're going to exercise from that process and all of the ancillary engineering processes that are going to happen on the side, that is vital to making sure that you're setting your team up to success for eventually realizing that big picture vision that you all can see as well. All right, next one. In SimCity, or for anybody who plays video games, this one makes a lot of sense. You have to know the rules, right? If you're playing in SimCity, you know it's all about resources and making sure that you're not constrained. And when you start the game, you start with something like this. You're picking how much money you're starting with, or you're making a selection about what era and generation you're in. That all has to do with the speed of how fast the development in your game is going to go. And so we're entering a new world of representing your data as a graph. And that introduces a whole new set of rules. I want to capture just one. I want to capture the main area that people stub their feet on when they're working with traversals for the first time. So a graph traversal. A graph traversal is a fancy way to talk about walking through your data. So anytime someone says traversal, you can flip it in your head and think walk. To me, every time I'm working with a customer, I see that you're starting on a vertex, and you know that you need to get a path maybe to somebody else. So when you're writing a traversal, you're trying to walk to the next vertex or walk through your data to get you from point A to point B. The rule that people are stubbing their toes on is the rules that come into play when you're dealing with your data's branching factor. Think about it. If you're standing on a street corner and you don't know where you're going, the branching factor is how many streets that you can select for where you're going to walk next. In a graph, your branching factor is how many edges that you have to go down in order to find the path as you're walking through your data. Visually, I like to do it like this. On this diagram, the vertex on the left is colored black. The vertex on the right is red, and that's where we're trying to walk from. The loose analogy is that each one of these traversers represents a thread, so that you're trying to process your traversal or your walk from the vertex on the left all the way to the vertex on the right. If you're walking blindly, every time you go from one vertex, you're going to split into 2 more threads that are required, and you're going to split again and split again. For the data scientists in the room, this is an exponential growth. As you're going down these levels, you are exponentially increasing the computational overhead required to walk from the left to the right. For the graph practitioners, you can do this more intelligently. You can select one edge or another. But loosely, when you're starting off at exploring your data and you're at the command line wondering why things are taking so long to return, what happened on the decisions that you made with your model, and what was your branching factor like as you were walking through your data? That's directly correlating to the response time and the speed that your traversal is taking. Ultimately, like when I was talking about finding your bulldozer, this all comes down to understanding the connectivity of your data. The data science inclined folks in the room, they need to have that chance to understand the distributions of your edges, and they need to understand for this type, on average, how many edges are going to be from this type to another type. That's usually why you see that bulldozer version getting into prod more like a data science area to study the connectivity of your data, because that is key for getting started. That also directly affects the operations of running graph traversals. Bringing it back to SimCity for a second. Because you don't want this to happen to you in your production application, right? You could have made some decisions when you were earlier on building and you ran out of money and you went into debt, and the citizens are now here to escort you from being the mayor of Gremlinville. Let's make sure you guys are taking time up front to understand the connectivity of your data, because you don't want your mob of citizens to escort you out of your graph project. It's a great analogy, I know. Number 3. So as you're going about this, you're going to be making mistakes. This is not also just specific to graph data. But what I can talk about are some specific mistakes that the community has shared here at this conference over the past 5 years, so that maybe those of you who haven't been at Graph Day, you can start to learn about what we have been saying has been failing. And if you want to see about how to make some mistakes really quickly in SimCity, this is what this would look like. So I had a prosperous community, one of those self-sustaining communities up in the right, and I had some free land on the left, lower right. And I just needed to get my infrastructure established, and clearly that is just not functional. There are disconnected bridges, power lines that are probably going to start fires. In general, this is not going to work. I forgot about my bulldozer. You have to use the right tool to get your infrastructure ready in order to be able to set up your graph problem. Use the right tool for the right problem. For us, and for the experiences that I have collected through advising companies and through this community and the conversations we have had, I like to collect these into 3 common red herrings of problems that I've observed and advised that are potentially setting you up to not be using graph technology for the right problem. So let's talk about those 3. This first one's really personal, because I think I was up here on one of the stages in this own venue a few years ago telling you all about this really sweet graph that I had built. I was here, and it was awesome. I was using Titan 053, and I had built a graph of the healthcare economy of the United States, my team had. And all of the vertices that you're seeing up on this screen represent doctors geolocated in the United States, and the edges between them were patients that they shared in common. All of you can already see there's a lot of really interesting things to start to infer about the economy of healthcare just by the patients traveling around the country. So we came to our executive suite with this really awesome solution for where we originally started. And for those of you who are data inclined, you know as soon as you give someone the perfect picture of their data, the next thing they want is more. And they're like, I need more answers. I need to know more information, and I need you to bring in this data set because that's going to get you in a new direction. And so they started asking questions about, well, for all of the customers who are using our platform, I need to know their overall load over time, and I need to understand the overall volumes that they've been giving us on a daily basis. And well, as we drew it out, it looked like this. Behind it, I had a GraphDB, and in front of it, they wanted a business dashboard. The citizens of my town escorted me out of my graph project, and I had to stand up a whole new stack in order to make that work. Please don't do this to yourself. It was the saddest day of my life to date. The second one that I commonly find is a mismatch of graph thinking down to graph tooling is the general problem of when you need to match keys and values according to their semantics, entity resolution, just general matching, such as there's these real-world entities, I have data about them, and I need to know that this thing is the same as this thing. That's all I mean by that. At first, this is one of the best illustrations of when graph thinking can lead you into an incorrect tool choice, because you can even whiteboard it. I'm sure some of you all in your teams have whiteboarded this exact problem. You're like, all right, so Jane from marketing, we've got Jane and her address is 1 Main and her ID over there is 123. And then my Jane from Salesforce has just her ID, but her name matches, we're good. But over here from the app, we have Jan and same address and same ID. But if you draw this on the board, we're gonna say this is good. Like they're the same, right? There's an entire industry that has studied this problem for decades. This is not a new problem. But drawing it like a graph and now the advent of graph technology has led people to saying, well, let's put this in a graph database. I want you to think back to that branching factor conversation we had and exactly why this is going to be a problem. When you were walking from one vertex on the left to your vertex on the right, for every edge, your threads essentially were doubling according to the branching factor. If you need to walk in this graph from Jane to Bob, you're now adding a multiple of 3 to your branching factor. Already something that was an exponential growth on computational overhead, we're going to multiply it by n. Great. This is really not going to be very performant if you're going to put your graph model like this, nor is this really a good way to solve this problem. If you need to do entity resolution and matching, let's find a different tool. It's great to talk about it this way, but there are better tools suited for it. And the third common red herring. It kind of starts off feeling okay. You're going to put all your people in your graph. They have names and they've got properties. This makes a lot of sense. And I've got a direct key to find my person. I've got their member ID. But once you get that stood up, someone else in the team says, well, hey, we've got other strong IDs. Can we look them up according to their social security number and their phone number? Well, what about doing semantic matching on names so we can kind of do some inferences on who with query patterns and who's the same? And all of a sudden, we have completely pivoted from our original goal of modeling relationships between people to building a search index on our people. We need to stay focused on what tool is going to solve which problem and why you're going down that route. There are others. These are the 3 most common. There's also going to be edge cases when, well, I made this work because I really hammered through it and it's going to be awesome. You're going to find spectrums on both sides, but the majority of companies that we have been advising and teams I've been working with, these are 3 examples of areas where a mismatch is going to happen between I want to think about my problem like a graph, and I'm going to use graph tech to solve it. At the end of the day, just remember, what are you really trying to do? When you're playing SimCity, because we got to bring it back up. We've got to go back to that since we probably forgot that we were talking about the sweetest video game of all time. When you're playing SimCity, you've got to, one of the rules is that everything has to be connected. Great graph joke in there somewhere. When everything has to be connected and you over-connect things, your roads can turn into a city game, like highways. They take up less space and they have more throughput. So make sure as you're getting down your problem, you understand the tool set that you have available. Well, that's going to bring you to a really fun debate that I'm sure all of you have been a part of in your dev team, making unpopular compromises about the tools and techniques that you're going to use. You guys, I'm sure, have done this 1,000 times. Well, this tool is going to be this performant. We're going to have a bake-off, and it's going to be great. And I'm going to prove to all of you that my answer is the best. When you're going down this route with graph tech, there's going to be a lot of unpopular compromises that you're going to make. And weirdly enough, one of the most unpopular compromises that I'm going to get into has a very weird definition or a weird way to look at it. But some of the unpopular compromises that you run into with SimCity are when, say, you're really strapped for resources. So you're really low on money, and you really needed to find a way to get money off of your, the simulation and the sims in your game. So you're going to legalize gambling. And then 3 game years later, we've got some other issues that you have to solve, right? That's something that happens when you're in SimCity, and that's very related to what happens when you have graph structures that look like this. What this is showing is that you might have a really common access pattern to need to have to walk from one cluster or one community and then connect it to another cluster or another community. So this query pattern from the black vertex to the red vertex on the left, that could be a really common query pattern for your use case. But there's really not a lot of value happening in that bridge in the middle. You can't really go anywhere else. So we commonly recommend a technique called a shortcut edge. It makes sense. You're not really gaining anything by adding 4 hops. We're just going to go ahead and build a bridge over them to make it a little faster. It's the common argument for denormalization. Except this isn't graphy enough, is what I hear every single time we talk about shortcut edges. We're not removing the graph structure. What we're putting first is efficiency. You need to remember there is a service downstream that needs this traversal. Likely, it could be a fraud detection model that needs to understand the distance between 2 points in order to effectively measure if a transaction is fraudulent or okay. And that needs to happen as fast as possible, probably at credit card swipe time. And when you're doing this, you need to remember that this is not new. We all use these things every day. You use them if you play SimCity like me, or you around your body of water just because you need to use the roads and bridges are not roady enough. No, that's not how that works. In SimCity, of course, you're going to build bridges because your citizens are going to have bottlenecks getting from one area to the other. One of the final technical sections, there are 6 lessons here. And this is the 5th one. It's the most technical before we get into kind of some wrapping points. Things can get catastrophic very quickly if you don't act decisively and you don't plan ahead. And for those of you who knew this was coming from having been SimCity aficionados like myself, this is my favorite part of the game. This is when you actually start getting successful and they need to start adding these monsters into your game in order to try and constrain your resources and make you lose. So when you're playing SimCity, this black octopus-looking thing will start to show up and begin to burn everything down. And they'll target your fire stations first because that's the worst. And it's one of those things that if you're not thinking about and preparing for it, this can get catastrophic very fast. So what's getting catastrophic maybe under the hood in your data model? It's a supernode. Supernodes are those vertices in your graph that just have a highly disproportionate number of edges that are adjacent to it. Kind of thinking back to in the red herring section to the graph that I talked about here at the Graph Summit before, you can kind of think of this as in that graph of doctors, that this doctor in the West Coast, not a supernode, only a few edges, not a problem. Over there in Florida, pretty obvious. There's a problem happening. We've got a supernode down there. If you guys weren't here when I gave that talk and are curious about the healthcare implications of that, let's chat during the hallway track of today, and I'll tell you about what was happening there. In order to understand the overall implications of supernodes, though, let's go back to when we walked through the branching factor. Again, the goal is to go from the vertex on the left and find your vertex on the right. And your traversal, even though you knew it was coming, you planned for it, you were OK with a branching factor of 2, you could hit a level where all of a sudden you didn't realize there was a supernode in your data. And those traversers are going to explode into hundreds of thousands or a few million different processes that need to figure out what's happening in this graph structure. This is clearly a problem. This is what takes down a cluster. So now that we're all real low saying, oh God, we've got major problems, there's ways to mitigate that. One of the first ways that we always advise about, that we talk about specifically with DataStax, is to make sure that you are tying together your use of Spark to understand the topology of your cluster, the topology of your graph data, and to monitor that over time. If you were to use DataStax just as an example, you can pull up the Spark shell, you can do a one-time test. A much more mature version of this would be at off-peak hours to make sure that you're monitoring the top most highly connected vertices in your graph. If you're using DataStax, this would be the way to do that today. You want to go to your graph. You're going to order all of your vertices according to the number of edges that are adjacent to each vertex, and take a look at the top 10. That's what this is going to be able to do as a process for mitigating and monitoring your supernodes. And I've said this a few times. If you have this going and you have this process monitoring your supernodes, and if you did build your team's bulldozer, it's about understanding the connectivity of your data. If you're going to step into using graph data in an application, its topology is of immense importance. It has performance implications for any production query, and it has performance implications for the data models that potentially are being created under the hood with wide partitions, or what other database implications that you would have. Your teams need to be monitoring this, and they need to be enabled to work together. You've got to build that bridge between data science and ops in order to solve these problems, and that is a hard bridge to gap. It's pretty intuitive when you get started with SimCity on how this applies. But when you're working with graph data, we forget to think about the topology and use the topology principles to drive our models. If either of these topologies came up for starting with SimCity, I can guarantee that you guys would all approach building your city completely differently. The map on the left, a little bit of water, some flat land, maybe some hills, rolling hills, no problem. I can kind of see a spot where to get my self-sustaining communities built. The map on the right, much more advanced. We've got much more significant issues happening with hills and the water around it. You guys would approach playing this game completely differently, and you can see it. We need to enable your teams to work together to see the topology of your graph data so that they affect your models, so that you avoid things like supernodes, and you can ensure that your traversals at runtime and in production are running as you would expect and that there's no surprises. And one of my favorite parts to kind of conclude here is to make sure that we're learning from past experiences. For any of you who have played SimCity a lot before or are about to use the rest of your weekend for this, you can imagine that what you're going to learn as you're playing SimCity really affects how you build the rest of your game. If you can even get here when you're playing in SimCity, that's a big win, and you're like, yes, I feel really accomplished. And the other items that you learned about playing the game to even get here are going to affect the steps that you take to build the next mega metropolis. If you're trying to get started and understand what this is going to look like for your problem, I'm challenging you to think about where you are, think about the data and the problem that you have, and to use this network here to learn from each other, to find out where you could stub your toe. But on the other side, get started. Pick up a tool that you want to try and see what kind of value that you can get out of your graph data. For us and for the graph community, this is a big transition from putting data efficiency first to putting data value first. And the difficulty between that transition is what we're experiencing. And the more that we collaborate, the more that we help out each other and listen to the other awesome graph talks that are here today, the more that we're going to help you guys get started a little bit higher from what we've been learning, having been here for the past decade or so. So in this last section, I want you guys to think about either the problems that you are working on now in prod, or the next graph problem that you're thinking you want to start about, and kind of go back through these 6 steps and think about where you can maybe adjust your plans to put these back into perspective. What is that bulldozer tool that you have set up for yourself? Did you skip that step? Did you go straight to, I'm going to show you this graph data because it's awesome and you need to see it? Make sure that you've set yourself up with the right infrastructure environment to get your project going. The second thing is that you need to remember to know the rules. I've always loved this one just because I personally felt like I was escorted out of my graph project when it failed the first time I tried to stand one up. You need to understand the business use cases that you're building towards. You need to understand the topology of the data underneath. And I could not have asked the previous keynote, Christian, to tee me up more perfectly for this talk. For those of you who are here, he had one of those example UML diagrams, I think, where all the relational tables and then all the connections between. That was starting to illustrate all of that topology and all of that branching factor that exists in all of the relational systems today that you're going to try and translate into a graph. You need to make sure you understand that during the translation. For the third one, just know you're going to make mistakes, and it's not a problem. You want to be here to collaborate and to make sure that you have the right process in place to get yourself into a successful graph application. If we want to chat offline about other things that have been super successful or have failed for you, I'd love to hear about them. Our main 3 ones that we see all the time are the BI dashboard problem, the mismatch of entity resolution, and then just search indices for everything. Those tend to potentially be a tool mismatch, but I would always love to hear about other ones or ways that you've made that work for yourself. And be prepared to have to compromise. Be prepared to collaborate, but also do so in a way that hopefully is going to get your project in a better place, because you want to make sure that the next wave of graph projects that we see are actually making it from dev and into production. And one of the final things to always remember is that the bridge between your data science team and your ops team is a vital bridge to have. You need to make sure that you guys have plans for handling catastrophes. You need to make sure that you are enabled to understand the topology and the connections within your data, because across that entire pipeline of your production stack, you're going to feel the effects of it, and you need to make sure you've planned for it. And this is exactly the community to be in, to learn from each other, to get started on your next graph application. So I thank you very much for being here in this talk today, and I think I have a few minutes for questions.